In this video, we're going to look at graphs of secant x and cosecant x. First, let's try to graph secant x with our graphing calculator. So, since we don't have a secant function, we need to change secant x as 1 over cosine x. So, let's make it into a fraction. 1 over cosine x. And let's go to zoom, trig. It looks like secant x looks like a bunch of parabolas going upwards and going downwards, isn't it? Now what I'm going to do is, for my y2, I'm going to graph cosine x and see what happens. Remember, secant x is in blue, cosine x will be in red. Look at this. Looks like there will be a vertical asymptote where there is an x-intercept for cosine x. There's going to be a vertical asymptote where there's x-intercepts for cosine x. At maximum, the secant is going upward. At minimum of cosine x, the secant goes downwards. So basically, in order to graph secant x, you first need to graph cosine x, find the vertical asymptotes, and see where the graph goes upwards and downwards. Now let's see the graph of cosecant x. So again, let's make it into a fraction. Alpha y equals, choose number 1 for fraction. So 1 over sine x. Let's graph it. Again, it looks very similar to secant x, but be careful, it's not exactly the same. Now, let's graph sine x and see how sine x is related to cosecant x. Just like the secant x and cosine x, cosecant x is related to sine x. Where there's x-intercept for sine x, there's going to be a vertical asymptote. And at maximum of sine x, cosecant x will go upwards. And at minimum of sine x, cosecant x will go downwards. So again, if you want to graph cosecant x, just like the secant x, you need to first graph sine x first, and then come up with the cosecant x. So if you want to graph cosecant of quantity x plus pi over 2, you first want to graph y equals sine of x plus pi over 2. So what is A? A is 1, B is 1, C is pi over 2, and we don't have D. D is 0. So the amplitude is 1, period is 2 pi over absolute value of 1, which is 2 pi, and phase shift is negative pi over 2 over absolute value of 1, which is negative pi over 2. So using these 3 information, we need to get sine of x plus pi over 2, but we first need to start from sine of x. This is sine of x, and we need to make phase shift of negative pi over 2. So in order to do that, we need to do 0 minus pi over 2, which is going to be negative pi over 2, and pi over 2 minus pi over 2, which is 0, pi minus pi over 2, That's pi over 2. 3 pi over 2 minus pi over 2. That's pi. And then 2 pi minus pi over 2, which is 3 pi over 2. So this graph, sine x, will move left, pi over 2. So we got negative pi over 2. This point will end up over here. And that point will end up over here. This one over here. This one over here. And that one over here. So this one will be now that is going to be y equals sine of quantity x plus pi over 2. Now our goal is to graph y equals cosecant of quantity x plus pi over 2. So what's going to happen is that there's going to be vertical asymptote at the x-intercepts of sine of x plus pi over 2. So let's draw vertical asymptotes. Okay, now you know that the cosecant is going to go upward at maximum. And at minimum, it's going to go downward. So these two curves represents one cycle of y equals cosecant of quantity x plus pi over 2. That's how you sketch this without the graphing calculator. Now we're going to graph y equals secant of x over 4. So in order to graph this, we need to graph y equals cosine of x over 4. So what is A? A is 1, B is 1 over 4, C is 0, and D is 0. What is the amplitude? Amplitude is 1, and the period is 2 pi divided by absolute value of 1 over 4, which is 1 over 4, and then 2 pi over 1 over 4 is 8 pi. So using these two information, we could graph cosine of x over 4. Since period is 8 pi divided by 4 is 2 pi, so each one increases by 2 pi. And here's a cosine when the period is 8 pi. This is one cycle. Now, in order to graph secant of x over 4, we got to find the vertical asymptotes. And you know that the vertical asymptotes happens at the x-intercepts of cosine of x over 4. So it's going to be at 2 pi and 6 pi. So again, at the maximum, the secant will go upward. So we get to see half of the graph. And at the minimum, it's going to go downward. Now again, on maximum, it's going to go upwards. So this is a one cycle of y equals secant of x over 4. This graph was simple because we didn't have a phase shift. Whenever we have a phase shift, graphing gets more complicated. So this is the idea of graphing secant x and cosecant x.